Hello, my name is Whitney and today we are going to be doing the balloon inflation experiment. This experiment is a chemistry experiment, so be ready, you crazy mad scientists. So today we are going to be needing 6 ingredients and materials. Our first one is vinegar. Our second one is baking soda. Any type of baking soda is okay. We're obviously going to need a balloon. We're going to need a water bottle. This is what's going to hold our experiment. It can be a soda bottle or a water bottle, just some type of container with an easy top. A measuring cup that measures to 1/2. And then lastly, we're going to need a funnel. Now, if you do not have a funnel, it's okay, no stress. I'm going to teach you how to make one out of paper. So first, you just get your sheet of paper, any size. It's completely okay. I fold it in half, hamburger style. Then we're going to grab one of the edges and just start rolling it in and folding it like this, and then you're gonna push out until you get a tunnel. So you want to just see it like a little hole right there. You're gonna get some tape and just tape up that edge, and then you have yourself a funnel. Just make sure that hole is visible and you're prepared, you are set to go. So our first thing is a 1/2 cup of vinegar. We're just going to pour this right into our water bottle. Be very careful, not trying to make a mess too badly here. And there we go, step 1, vinegar into water bottle. We can set this off to the side real quick. And now we're going to grab our balloon. We're going to stretch it out just a little bit. And then we're going to get our funnel. And we're going to insert the funnel into our balloon. Making sure nicely in there. You can squeeze the ends a little bit. It helps it fit inside just a little bit better. Then we're gonna get our baking soda and we're gonna pour some in. I'm gonna do mine to the count of 3, so count with me. We go 1, 2, and 3. We're gonna shake it down, make sure it's all in there. See how much we have right now? Right there. You think that's enough? I don't think so. We're gonna add a little bit more in here. Count to 3 one more time. 1, 2, and 3. Give it a little shake, make sure all the baking soda is inside of the balloon. Okay, we can't see anymore. We're going to take it out. And then you should feel all the baking soda at the bottom of the balloon right here. So right here. Next, this is the careful part. You got to be really careful. We're going to get our water bottle and our balloon. And we're just going to stretch the edge over. Just like this. So only the edge. You want to keep the baking soda at the end of the balloon and make sure it's just hanging out like that. So now we're going to raise the balloon and insert it into the vinegar. Now what do you think is going to happen? Let's think about what we have here and the materials we're using. Balloons are known to do what? If you said inflate, you are correct. When we see balloons, they're usually flying around in the air. You know, we hold them down with a string. Our balloon is tied to our bottle, but it should still inflate. Vinegar and baking soda work together to create carbon dioxide, which inflates the balloon with the gas, just like this, and we can see it blowing up. And then within the water bottle, you also can see it fuzzing as the two chemicals react to each other, and we get an inflated balloon. How cool is that? Alright, so I'm going to put Mr. Balloon to the side here. That was pretty cool, right? Let me see. We're going to name him Bob. Just going to put Bob right over here for a second. So just now we saw how these two materials react to each other to create a reaction. Our reaction is the gas, which is inflated. So let's try this a little bit differently with a larger bottle, a larger material. So we're going to do the same thing, same setup, and I just want to hear what you think is going to happen going from a normal sized water bottle to a slightly bigger bottle. Okay, so right here I have 1/2 cup of vinegar inside the bottle, and then I did my 6 count for baking soda just to match, to make sure we have the same amount as we did in the original one. We want to keep these things constant so we can see the change. So the only thing changing right now is the volume of our bottle. Alright, so let's see what's going to happen. It's inflating as it should, but do you notice something? It's slightly smaller. then the first one. Oh, actually, it's still blowing up. Both balloons have blown up, and this is actually kind of, look at the way it's standing up. They are relatively the same size. Now, I know at first we're like, wait, it seems like it's going to be a tiny bit smaller, but if you think about it, the reaction still happened right here, right? And the gas is still created. Same amount of gas has been created to do what? To blow up the balloon. The space in which the gas is traveling is still the same. So that is why when we look at both balloons, they're relatively the same size. This one has been sitting off to the side for a minute, so that might be the difference, but you can see exactly right here. The reaction happens in the chamber, and then it goes up right here straight, and then it expands the balloon here. So it's really cool to see on this scale how this reaction, it doesn't really matter where it's happening if it's going to the same place. Lastly, I want to test out one more thing for y'all. So we know we're creating a gas, right? Using a liquid and a solid. How are liquids and solids created? We know they're in reaction to their environments, right? So think of like ice to water to, you know, air particles, like your rain. When after it rains, it gets really humid outside. What changes these things? What makes ice turn into water? Heat. And then heat, yet again, makes water into humidity. So let's do the opposite of that. If you want to go backwards, you make it colder, right? Versus hotter. So I'm going to go grab some cold vinegar, and we're going to do the same experiment, but this time with a cold variable instead. Okay, so I'll let it focus for a second. Hello. Alright, so I am back, and this time I have cold vinegar. You can kind of see the condensation building at the bottom of the bottle, and I have the same amount of baking soda. So let's see what difference will happen. What do you think is going to happen knowing that we're using cold vinegar instead of like room temp vinegar? Let's see. We have the same reaction building up. It's inflating the balloon. But do you see what's happening here? It didn't continue inflating. It inflated slightly, but now the reaction is actually happening within the balloon. You see that color change? The fuzz is up here. Isn't that crazy? So let me explain what just happened here. When we talk about temperature in reaction, in combination with reactions, I said earlier how heat will make something melt, right? It makes it speed up. So particles, when they're heated up, they get all excited, they're moving all around, but then when they're introduced to cold and a decrease in temperature, they start slowing down. Just like us, on a cold, rainy day, we like to snuggle into our blankets and stay warm and just steal. That's the same thing particles do. Instead of expanding and going all over the place, they start slowing down a bit. So when this reaction occurs with the cold vinegar, it's gonna go slower and slower, and the gas particles aren't moving as quickly to expand the balloon. Now, as we set this out for a minute and it starts warming up, the crazy part is the reaction is still going on, right? Because it's taken a longer time. That's the only thing. It's taken a longer time for the reaction to occur. And so then the balloon's gonna not really slightly start increasing a bit as the reaction time runs its course, but you can kind of see the condensation within the balloon, which is really cool because you can still see it happening down here. It's still fuzzy and it's still cold. So this was our reactions today, in which we tested just baking soda and vinegar. You can use this in more than one situation. People use these all the time for volcano projects, but to show you right now is the balloons are to show the gas that's emitted and what it does. So CO2 is what's produced, which is what's blowing up these balloons, and the funny thing is, we produce this every day. Obviously, we don't have vinegar and baking soda within our body. When we breathe in oxygen, we're exhaling CO2 into our environment. So it's really cool. And I hope y'all learned something new today and had some fun while doing it. And always remember, pick them.